Hey class, today we're going to look at section 2, which is about forces and pressures in fluids. In the last lesson, we talked about pressure and how it is force divided by area, and a couple other things with pressure, such as it increases with depth and it decreases as you increase the altitude. Today, we're going to focus on two major principles when it comes to forces and pressure. And as a little introductory, it shows a picture of a blow dryer and a little tennis ball, or ping pong ball is what we call it for table tennis. And it states the fast moving stream of air from a blow dryer creates a column of low pressure air. The tennis ball is suspended in the area of low pressure. And we're going to talk about why that is, what we see, and why we are able to see that. So let's get started with one of the first principle we'll talk about out of the two. This one is a key question, so please make sure you start in your notes. The question states, how does Pascal's principle describe the transmission of pressure through a fluid? First, we need to understand, what does transmission mean? Transition means just how does it flow, or how is it passed through a fluid? Well, according to Pascal's principle, a change in pressure at any point within a fluid is transmitted, or it is going to move through a fluid equally and in all directions. So if you're a visual person like me, hopefully this slide will help you. The first bottle is a picture of a bottle. Of course, it has a fluid in it because remember, a fluid can be gas or a liquid. And the second picture shows the same bottle, but it's being squeezed or a force is being applied to it. So in bottle A, one thing I do want to point out is it states that forces are going to be exerted on the walls of the container. So that's why we see red arrows all on the walls of the container. And it also wants you to notice that if they're equal at a given depth. So notice that right here in the middle, these two arrows are the exact same length because they're at the same depth, so same pressure. Also, I want you to notice that the arrows at the top tend to be shorter because there's less pressure up top. And then, of course, the arrows on the bottom are going to be bigger because there's more pressure at the bottom, because pressure increases with depth. Now, when you apply a force, such as squeezing the bottle, that pressure is transmitted equally. And when I say it's transmitted equally, it means that all of these arrows are going to increase by the same amount. Even though you're pressing in the middle, the arrows in the middle not only increase, but the ones on the top and the bottom. Note that the top still is going to have the least amount of pressure and the bottom is still going to have the most. So here it says at any given point, equal pressures act against all points of the inside of the bottle, and when you squeeze it, the pressure is going to still increase with depth, it just increases equally in the same way. So for example, if I had $10 and my sister had $5, and we had equal raise, maybe I get 15 and she went to 10. So we still equally got $5, but I still have more. So with that principle is the idea of hydraulic systems. And so our key question asks, how does a hydraulic system work? First, you kind of have to understand what exactly is a hydraulic system. It is defined as a device that uses pressurized fluid. So here we're talking about fluid and pressure, and it acts on something called a piston. And the whole point of this is to change the size of a force. So here we want to change the size of a force. And you may say, Mrs. Grove, I'm not sure what a hydraulic system is or what exactly a piston is. So I'm going to go flip to the next slide and then I will flip back to kind of give you a visual. So an example of a hydraulic system would be right here in this truck. Say you had a truck and it was hauling something like rock or corn or something heavy. In order to release that rock or corn, typically these trucks have a hydraulic system located right here that lifts up that super heavy load in order to dump it out. And then over here, we have examples of a close-in drawing version of what exactly is happening. And this little thing right down here is known as a piston. Up here, this one's known as a piston. So To answer the question, how does a hydraulic system work? It says, in a hydraulic lift system, an increase in output force is produced because the pressure is exerted over a large area on the output piston. Right now, that may not sound like a lot. So again, let's go back to our visual and describe it a little bit more with something to look at. So I'm going to label a couple things on this, and I highly suggest that you label it in your guys' notes. Here, this small arrow is known as the input force. Here, this is known as the small piston, and it's called a small piston because it has a small surface area right here. The yellow right here is going to be our pressurized fluid. And then up here, this is known as our large piston. It's called a large piston because it has a large surface area here. And then this arrow up here is our output force. So a couple things to make you aware of. Input force is the force that you put into something. Output force is the force that is generated or that's created. And notice that you can put in very little effort here or very little force and still get a very big output force in. So you can barely use very much energy and then it creates a big response. So here, this is how it works. You apply an input force. This input force is going to be applied to a small area on the small piston, and so it creates pressure. Now, because of Pascal's principle, that pressure is exerted equally in all directions. So notice that all the arrows here are of equal size. However, when it gets over here to the large piston, that same amount of pressure is going to be exerted over a larger area. And because it's exerted over a larger area, that gives me a bigger output force. This slide basically goes into detail in words what I described on the last one. So it says when an input force is applied to a small piston in a hydraulic system, the piston is going to push against the fluid sealed in that system. So again, the pressure produced by the small piston is going to transmit through that fluid all the way till it reaches the large piston. Now, even though on both pistons the pressure is the same, the area, so it says the output pressure acts on a much bigger area, so my output force is larger, and it can lift a heavy load such as gravel. The second principle that we're going to learn about is something called Bernoulli's Principle. And Bernoulli relates two things together. He relates speed and pressure. So our question says, how is the speed of a fluid related to the pressure within the fluid? Well, according to his principle, he states that as speed increases, fluid pressure is going to decrease or go down. So you can try this simple experiment if you get a single sheet of paper and hold it at the corners and then position that paper directly in front of your mouth. You want your mouth to be over the top of the paper. You can blow over the top of the paper and you'll notice that the ends of it, the far ends, tend to start lifting upwards. Now, why does it do this? Well, as you blow air across the top of the paper, the pressure exerted by the air is going to decrease. So here, let's say I have paper. So here on the top, it says that my pressure decreases. Now, the reason my pressure decreased is because my speed, when I blowed the air, caused the air to increase in speed. Now, below the paper, where I'm not blowing, I have motionless air. So my speed is actually pretty low. Oops. And my pressure is pretty high. And this creates a difference in pressure. Notice I have low pressure on top, but high pressure on bottom. Well, one thing I want you to write down in your notes is pressure flows from high to low. We don't like this pressure difference. So this high pressure on the bottom tries to flow up to the top of the paper. So when it does that, it pushes that paper up. Bernoulli's principle helps explain the ability of birds and airplanes to fly as well using this same technique. Air traveling over the top of an airplane wing tends to move faster than the air passing underneath it, and they control this using flaps on the wings. And this pressure difference between the top and the bottom, like we talked about with the paper, causes an upward force known as lift. So air flowing over the top of the wing is diverted up and over the wing's curved surface. Now, the wings of a bird produce lift a lot the same way that an airplane does, but unlike an airplane, birds can actually flap their wings to produce some of that forward and up movement. The other example we can use is something called a spoiler on a race car. This actually creates a downward force instead of upward force, but Bernoulli's principle is still used. Now, if you're anything like me, you might be like, what is a spoiler? This is an example of a spoiler on a car. So it says right here, spoilers are used to push down on the tires and give the car better traction. So how exactly does it do this? So spoilers are created and shaped in a way in which we have high speed below the spoiler, which creates low pressure. And then above the spoiler, we have low speed of the air or fluid moving, and this creates a high pressure. Well, remember, pressure wants to go from high to low. So air is actually going to push down on the spoiler. That's going to push your tires down better on the ground and create better traction. The last example we're going to use is spray bottles. So if you've ever used fertilizer or anything like that you have to hook up to a hose, pressure differences are created to draw that fluid out of the bottle and connect with the water from the hose and then spray out. So here we have a fluid, this is fertilizer, and it's not moving. So the speed is going to be slow. And my pressure is going to be high. Up here, the water moving through the hose, this is moving water. So this is at a generally high speed and low pressure. Again, notice I have a pressure difference. This difference in pressure, remember pressure wants to go from high to low. It's going to draw the water up the spout where it mixes with water and then sprays out. Okay. And that's the end of today's lesson. If you guys have any questions, please make sure you ask. And otherwise I hope you guys have a great day.